Cherenkov radiation is a phenomenon that occurs when a charged particle passes through a dielectric medium at a speed greater than the phase velocity of light in that medium. However, it's important to note that Cherenkov radiation does not actually exceed the speed of light in a vacuum. In a dielectric medium, such as water or glass, light travels at a slower speed compared to its speed in a vacuum. This reduced speed of light is known as the phase velocity. When a charged particle moves through the medium at a speed greater than the phase velocity of light, it emits electromagnetic radiation known as Cherenkov radiation. Cherenkov radiation appears as a faint blue glow or sometimes as a cone of light surrounding the path of the charged particle. The angle at which the light is emitted depends on the speed of the particle and the refractive index of the medium. It's important to clarify that the speed of light in a vacuum, denoted by c, remains an absolute constant according to our current understanding of physics. According to Albert Einstein's theory of relativity, no object with mass can reach or exceed the speed of light in a vacuum. The phenomenon of Cherenkov radiation does not violate this principle because it involves the propagation of light in a medium rather than in a vacuum. In summary, Cherenkov radiation does not involve the actual exceeding of the speed of light in a vacuum. Instead, it occurs when a charged particle moves through a dielectric medium at a speed greater than the phase velocity of light in that medium, leading to the emission of electromagnetic radiation.